You call it as a neighborhood operation because we are dividing it into so many sub-images, and this mask moves over all the sub-images and performs this computation, resulting in filtering of the entire image. So the whichever the image, the 3x3, 7x7 is acting upon this one, this is called as the mask or the kernel of the image. So depending upon this mask, so here we are now going to consider, having known about what is meant by filtering and how this is being done. Now we are going to describe about various masks based upon the characteristics of the mask. The characteristics of the filtered images could be seen. So whenever you have it also depends upon the application where you are applying and how the image is corrupted. That is what you are trying to filter out, whether filtering out noise or filtering out errors or blur or whatever it is. Accordingly, you will choose the mask. So mask has got so many values. Mask may be some standard mask as well. So some standardized values are being put up and you will have some standard mask. So apart from that, we can develop our own kernels also. Based on our application, we can also develop our own kernels. So whenever this kernel or this mask moves over the image, the requirement, our main objective of filtering, noise removal or blur removal or whatever it is, gets satisfied. So basically, it is the application of mask over an image. It is a neighborhood operation. It is a point operation. It is also called as filtering operation, filtering in spatial domain, since we are performing it in the spatial domain. So two types of filtering can be seen here: smoothing filters and sharpening filters. So again, this smoothing can be carried out using average. So averaging filters are also called as smoothing filters. So here averaging takes the very same meaning as we normally used to understand it. So averaging will be a representation. That is, you will have some n number of representations. So out of that, we will take one in the representation. So this is what is averaging. So n number of people in a class average, we say. So n number of data, average data, we say. So likewise, so I am going to perform the very same averaging operation here. So you can see some averaging mask here. So this is one type of mask. Everywhere once we are having. So totally it is a 3x3 mask. So 9 elements are there. So I am performing the averaging function here. This is a very standard procedure of averaging. And you have got some weighted averaging as well. That is, somewhere you want to give more thrust and somewhere you want to give a little bit lesser thrust. So in that case also you can develop some averaging mask. So I am going to have the total value here as the denominator value. So I am performing the averaging using weighted average also. So these averaging masks, as we do normal averaging, normal mean, here it causes smoothing of the image. So what it does is, somewhere you will have high intense noise pixels. Somewhere you will have low intense image pixels. So likewise, some 40% noise is there and the remaining 60% signal is there. So this 40% of noise will be completely distributed throughout the remaining image. So as it is distributed throughout the image, the intensity of noise will come down. But at the same time, it is not getting eliminated. It is being distributed, isn't it? So because of that, it causes a smoothing effect. So sometimes it may cause even a blurring effect. So this sort of an outcome is what this averaging mask does. So whenever you perform averaging filtering, it causes smoothing of the image.